Hello, this is FlippedHarber for Algebra 2. This video will cover section 2.9 absolute value functions. Our objectives for this section are to graph and transform absolute value functions. Our topics include the absolute value functions. An absolute value function is one where it includes an absolute value of the variable x. Now there may be other numbers inside with the x. There may be numbers outside the absolute value. But basically, whenever you see the x inside an absolute value, it's an absolute value function. Now our domain for absolute values are all real numbers. We can plug positive numbers, we can plug negative numbers into that absolute value. But we can only get out positive numbers from this basic absolute value function. And notice that it makes a nice V shape when we graph it. The right side of the graph has a slope of 1. The left side of the graph has a slope of -1. Now when we want to transform absolute value functions, everything that we learned in section 2.6 still works. All of my rules about inside changes and outside changes still holds true. When we talk about translations, horizontal translations, we're talking about subtracting a number inside the absolute value, inside with the x. If we want to do a vertical translation, we add that number to the end. Stretches or compressions, again, we divide when we're inside the absolute value, we multiply when we're outside. Reflections still happen the same way. If we want to reflect over the y-axis, we put a negative inside with the x. If we want to reflect over the x-axis, we put that negative outside of the absolute value. So we're just taking all the things that we learned in section 2.6 and using it with a new type of function. And we're going to do this several more times through the course. Let's transform the basic absolute value function by moving it 5 units down. Now we're going to accomplish this by subtracting 5 from the end of the function, so that -5 is outside the absolute value. Our graph looks exactly like the original function, but it's been moved down 5 units. So that V, that corner, which is actually referred to as a vertex in math, is down 5 units at -5 instead of at the origin. Let's move the basic absolute value function 1 unit to the left. Now this is a horizontal change, so we're going to do something inside the absolute value. And remember, changes inside the absolute value are opposite what we would expect. So we actually add 1 inside the absolute value. Graphing it, that nice V shape just shifts to the left 1 unit. Let's translate the absolute value function so that the vertex is at -1, -3, meaning that it's been moved down 3 and left left 1. So we're making a change both inside and outside the absolute value. And there's our graph. Let's reflect this absolute value function across the y-axis and graph it. Now whenever we want to reflect across the y-axis, we multiply just the x by a negative. We don't do the whole function, just the x. So just the x gets that negative. And there's the graph. The vertex started at 2, 3, but it was reflected over the y-axis and is now at -2, 3. Let's stretch this graph vertically by a factor of 2. So we learned in section 2.6 that in order to do a vertical stretch, we have to multiply the entire function by 2. So when we distribute that 2, there's a 2 in front of the absolute value, and we multiply that 1 by a negative that negative 1 by a 2 also. And here we see the original f of x in the pale pink and the new g of x vertically stretch by 2. So that vertex got pulled twice as far away from the x-axis. The two x-intercepts didn't move. Under vertical stretches and compressions, the x-intercepts do not move. Alright, that's it. We're just applying a lot of stuff that we all already knew, so hopefully you're getting more comfortable with it. It's time to get started on that homework. I'll see you in class, and I'll see you online.